the revised course outline, reading resources, and guidelines via email for your kind perusal. Before we start today's session, I would like to remind the housekeeping announcements once again. Kindly join the meeting on time. There will be a Q&A session after each presentation. Share your questions in the Q&A box. The questions must not be posted as anonymous attendees.
Yeah, so I think now you can see the screen, right?
Yes, sir, it's visible.
Yeah, so like what we did in the previous class, let me try to continue doing that, which is so we were actually talking in terms of few things. The first thing what we were saying is what is the use of uh, what is the use of your this thing, you know? Why we want to uh, learn this distribution function, right? So we said that the reason why we wanted to let's see, I think my this thing is not working. Let's open a notepad which should be doing the thing. So here basically what we are trying to do is we were, are you able to see my notepad?
No.
No? Oh. Just okay, I'll just write it here. I think this is creating a problem. So let's say I will share my this thing, you know. So let's forget about all this. Let me share my Excel file. Yeah. So in the previous class, if you remember, we were doing few things. I think you can now see the Excel, right?
Yes.
So the first thing we were doing, I'll write it over here so that all of us are on the same page. We were talking about why distribution and density function, why these are important. You know? And to which we said that we wanted to understand that if we want to understand any outcome variable, and we wanted to understand that which sample is performing a better job in terms of the outcome variable, we need to understand the distribution function. So basically, we need to understand the distribution function, or for that matter, the density function, because we wanted to understand within which sample the outcome variable is doing a better job, right? So this is where we started. And if you also remember, we said that we were kind of giving an example of two sample of class uh, class students, you know. Is it ringing a bell that we said that in one class, and both this sample, uh, let's say they have 40 students each, okay, 40 students each. And I said that in the first sample, you found that the mean, let's say that, let's call this as the mean, and the standard deviation. And please ask question if you, so in both the sample, we have 40 students each, but in the first sample, we were getting a mean of 75 and standard deviation of, let's say, 3. In the second sample, we were getting a mean of 70, but the standard deviation was less, right? So we wanted to understand that which one of this sample is actually doing a better job, right? Are you guys remembering? That's where we started, you know. And we said that the we will have to use typically we use t-test statistics, right? Um, and we also said that t-test statistics and your normal distribution both are kind of same thing, provided your number of observation is greater than 35 or around 35. If it is greater than 35, this is also called the law of large number, when we see that the t statistics is asymptotically converging to the normal distribution. And the normal distribution is that nice bell-shaped curve that we were discussing in the previous class. And we also said that when we are trying to do any hypothesis testing, and today I'm going to show you how to do the hypothesis testing, we need to understand this normal distribution. Okay, so this is what we were dealing with. Guys, any question on this as to what we did in the previous class and what we are doing now? Please, you can ask your question in the chat box. I will try to answer. Okay. So in the previous class, I kind of told you that it also depends upon the what's your objective, because if my objective is to uh, get number of students admitted to any competitive exam like IIT, then for me the first sample would be a better choice, because here I find that there are more number of students who are actually scoring more marks. But if my objective is try to ensure that all the students uh, uh, are equally getting or understanding the subject, then as may happen in the case of primary education, uh, you will find that the maybe sample 2 is doing a better job, because here the standard deviation is less, which is telling me that more number of students are actually getting equal marks. Okay. Now there are two questions. Ambika is asking whether the number of observation is greater than 30 or 35. Ambika, it doesn't matter much. I will show you. In many cases, all it matter is the p-value. Okay, so I'll tell you what does p-value mean. As you please write it down as we go through, and also what matter is. Aditi is asking question, the standard deviation formula for population versus sample was giving slightly different result. Again, it doesn't matter much. We typically tend to work with sample standard deviation, because remember, Aditi, I said that in case of sample, what in the denominator you have n minus 1. Okay. In case of population, in the denominator you have n. Okay. Now, if n is quite high, whether you divide by n minus 1 or n, it's not going to matter that. Okay. And I'm going to show you something which I've not said in the previous class is we spoke about t and normal distribution. There is also called uh, Z distribution, which is standard normal distribution. Now, Z distribution is basically coming back to the question which Aditi was asking, that in case we know about the population parameter, okay, population parameter means we know about the population mean, we know about the population standard deviation, then we can use the Z statistics. But in most of the cases, it is difficult to get an idea about the population mean or standard deviation, and therefore we 99% of the cases you'll be using what I would say the test statistics. Okay, so let's start doing with this example. Okay, because this is something similar all of you can see my Excel file, right? Um, so, so this is similar to what we were doing in sheet one, which is here you have this two sample, and here, as I said, that in both the sample you have 40 students, okay? But if I were to ask you that which one of the sample is better, so this is what we were trying to understand, that which one of the sample is better. Again, I said that it depends upon what's your objective function. If my objective function is to run a coaching institute where I want to see more number of students qualify for IIT or any competitive based exam, then maybe the first sample. But if my objective is to run any primary school where my main objective function is to ensure that more number of people understand the subject. I don't care about too many brilliant people, but what I care about is most of the people actually understand what I'm saying. For instance, what we are doing now, I don't care about whether there are one or two outliers, but what I care about whether among all the participants, most of you are actually able to understand, and therefore a lower standard deviation. Okay, but thankfully there is something called pairwise t-test, pairwise t-test, which allow us to understand which one of the sample is doing a better job. Okay, now the formula for this pairwise t-test, I don't know, I don't remember whether I have given in the previous class. It's basically uh, x1 bar. I am actually okay. Let me write it down. X1 less x2 over. So what is x1? X1 is the average. Okay, x1 is the average of the sample of sample one, which is also the mean of sample one. Okay, this is what we were discussing. X2 is again, what is X2? X2 is the average of sample 2, and which also means it is the mean of sample 2. Okay, so this is mean of sample 2. Okay. Now, the formula for the pairwise test is this over what you have is the square root of S1 square. Okay, S1 square is the S1 square to the power 2 over N1. I'm just going to explain each one of them, so just hang on. Plus S2 square over N2, and this actually raised to the power half, which is basically raised to the power half, which is basically 0.5. Okay. Now, did you so check over here the formula which I've written, and I'll just do this right now with you guys, and Dr. Arjun is going to share with you this database so that you can actually try doing it on your own. Okay. Now, you remember in the first class I said that whenever we are doing anything, we wanted to actually uh, uh, we wanted to actually motivate this discussion that why we are doing what we are doing. Okay. So one of the question which Arya is asking, let's say whether I can use the notepad over here, but for this, so Arya, the formula is, I'm just repeating so that you know what I've written. So here is the formula. Formula is x1. So let's say I have two samples. Now you will actually see it. Okay, what I'm doing is, so what I have is, let's say that you want to play in the stock market. Okay, which many one of us try to do it. And I have, and by the way, this is the real data which which I have actually collected from NSE Index, NSE website. Okay, and how many of you, roughly, I'm sure that some of you actually participate in the stock market. Okay, uh, so here, what I have is I have two stocks. Okay, and this is the closing price of Adani Power and closing price of Tata Power, and you will notice that both these stocks are coming from the same industry, which is power sector. Okay, because why? Because I don't want to pick stocks across industry, because then I cannot compare. But if I were to ask about picking a particular stock within a particular industry, then it makes sense that which one of the stocks should I pick. And if I ask you as an analyst, and here to answer this question, that without, I'll show you how we can do the pairwise t-test, because so if I ask you this question, that just by looking into this data, which one of the stocks should I invest? Or is there any big difference in the data that I see? What would be your answer? Let's try to open this so that I can also understand your thought process. So if I ask you that I'm a guy who's sitting with money, and I okay, PA is saying Adani, but PA, whosoever you are, I don't see your, okay, Purnima. Okay, so Purnima, why Adani Power? If you can write. So Purnima is saying that she would actually pick Adani Power on the basis of this. Per stock value is high, but okay, yeah. So Tripta has done me a favor, which is she has written down the formula, but I'll just do it right now. Okay, let's come back to Purnima. Purnima is saying that the per stock value is high, but that's fine. But Purnima, what if I enter? So when you buy any stock, do you see? So in that case, I can always argue that it is better to buy TCS, because the value of TCS is much higher than any one of this. TCS is now trading at so now I have a much more interesting answer. Vaishali is saying Tata Power growth rate would be more. So when you are actually buying a stock, you want to ensure that whether you are making profit or not. Okay, just by looking, because I can see that clearly from here, I can see that the Adani Power has got on average more number, but that is fine, because I can enter at 373. But if I were to sell it at 368, I make a loss, right? So doesn't matter. Now, in order to try to address the question which I think both Purnima and Vaishali are raising, let's try to do a pairwise t test. Let's try to do this. Okay, so pairwise t test, again, what it is saying, that on an apple to apple basis, meaning that if we are just looking into this, I need to understand that where should I invest. Now, coming back to what Purnima says, I don't have to do or run the pairwise t-test statistics, because you can see that in most of the cases, the value of Adani Power, I'm repeating what I'm saying, the value of Adani Power in most of the cases is higher than the value of Tata Power. And therefore, if I run a t-test statistics, it will be highly significant, meaning what? Meaning that it is going to tell you that the mean average price of Adani Power is going to be higher than Tata Power. So let's try to do this pairwise t-test. So this is how you do it. You again just And please use this whenever we are doing this because I've shared the data file. So please use this standard diff, and this is my standard deviation. Okay, now let's try to do the t-test. T-test is basically saying x1 minus x2. Okay, so first let's try to derive x1 plus x1 plus x2. This is equal to how much? This is equal to x1 is this one plus x2 is this one. If you don't understand, please ask me. So this is what I get, x1 then. Now I have to derive this part, the denominator part. Okay, now let's try to first do this one, s1 square s2 square. So first let's try to derive this one. So this one is s1 raised to the power 2. Okay, so basically we are talking about the variance. So in this case, s1 is how much? S1 is 50.47. Okay, just so you know, let me write it down so that there is no confusion. Once you check this, S1 is how much? S1 is 50.47 and S2 is 9.56. Okay, 50.47, 50.47, and S2 is 9.56. Okay, now S1 square would be how much? So this will be this raised to the power 2 over what I have is n1. Now n1 is the number of observation. Okay, so I don't know n1. So let's try to see what is the number of observation. So I've just squared both of s1 square and s2 square, and an easier way to understand what is the total number of observation, this is the formula. You write count, and then you go from here to, because many times we tend to do mistake in terms of count. So we have total number of observation as 63. So both n1 and n2 is 63. So this is the square, okay, square of standard deviation. Or let's put it this way. Let's write this as a variance, okay, so that you don't forget. So both n1 and n2 is 63. Now all we have to do is to, because we know this, so s1 square over n1, so this would be this over 63, right? And this would be this over 63. This is what I'm getting. And finally, if I were to look into this number, okay, if I want to look into this number, what I'm getting as this is equal to this plus this. This is what I'm getting, okay? So this is number. Now, this does not entirely, so I have to now take the square root of this, okay? Square root of, as you can see. So we have now derived this number, okay? We have now derived this number. Now I have to take the square root of this number, okay? So the square root of this number is, you can write SQRT over this one is what I get is 6.47. So this big denominator, okay, is what I get is 6.47. Everyone clear? Any question? Any question? Anyone? Okay. So so in this case, what will be the value of t-test statistics? So my denominator is 6.47. Okay, let's try to give a different color. And my numerator is, let's see, is this one. So the test would be this over this. 18.59 is my t-test statistics. Now, what does it tell you? Now let's try to open this up, because otherwise you will not get the fun part of it. So what does this tell you? My t-test statistics is 18.59. Now let me introduce another concept, which is called the p-value. Okay, the p-value of t-test. And in the previous class, I said that whenever the t-value, the rule of thumb is if it is greater than 2.5. Okay, if the t-value is greater than 2.5, the rule of thumb is the t-statistics is going to be, so let's put in this way. If this is greater than 2.5, then t-statistics is going to be significant, highly significant. Okay, highly significant. So that's where we are getting. Now the p-value of t-statistics is basically telling you that you remember that in any statistics book, at the end of the book, you will have the degrees of freedom and the critical region, so on and so forth. Forget about the book. This is the new age. So it's very easy to find out that whether this particular thing is statistically significant or not. And for that, you have to write this formula. It's called t dist. And the moment I give t dist, it is asking for, see, x is this value. Okay, degree of freedom is, we have the number of observation less 1. Okay, because we are losing 1 degree of freedom because we are dealing with the difference in mean. So what is the total number of observation? It is 63. So I have 62, and tail is, we are trying to understand that whether there is any significant difference. So it is a two-tail test, and you will find that this is almost equal to 0. Okay, so it is almost 0, because what you see here is 4.725 11 e minus 27. It means that point followed by 27.0, then this 4 term will come. So it will be something like 0.0000. I have to type like this 27 times. Okay, and then you will have this 4. So this is highly significant. So coming back to, I think, Purnima's question, it does not require us a great deal to understand that which one of the sample has a higher mean, because I can just, by looking at the data, I can actually say that this Adani power has a greater mean. But Vaishali asked a very important or pertinent addendum, which is it the, because if I just draw TCS share price here, okay, you will again find that in case of TCS, if I look into the closing price for TCS also, it will be highly significant. So what is the big deal here? So there is something we are missing. What we are missing, that if we were to pick between Adani and, let's say, Tata Power, we should not look into the absolute number. What instead we should be looking at is the growth rate, because what we are more interested to understand is where, if I put 100 rupees, will give me a better return. Okay, so I have, I think, okay, so Surya Teja Bandela, difference of mean is divided by standard error of deviation. Now, Surya Teja, standard error of the sample. Okay, so there is nothing called standard error of deviation. Deviation is itself a standard error. So standard error of Adani Power plus the standard error of the square root of standard error of Tata Power. If that answered your question, that is the answer. Okay. So anyway, I have actually, if you can see my screen, this is the formula again, just so that you guys are on the same page. So this is what we did here. This is the formula for the t-test, but here the t-test is not doing much help, because why? Because anyway, I can see that the mean of this one is higher than the mean of this one. Okay, so and therefore it does not require us to do or know all this formula, all this sophisticated formula. Okay, but again, if I were to actually understand which one of these stocks should I invest, now what I should do is, let's insert some column. So here I should actually look into the growth of, this is I think what Vaishali was trying to argue, growth of Adani stock price and the growth of Tata Power stock price. Okay, and then you run a pairwise t-test statistics to understand which one is going to give a better return. Okay. Okay. So this is, then you run a pairwise t-test statistics. Now let me ask you guys a question, and let's see that whether you have understood this or not. Let's say that I run the pairwise t-test statistics, and I find that Yogesh actually, Yogesh is saying that Tata Power has got more consistent price. So the consistency we are measuring in terms of the standard deviation. Okay, Yogesh. But actually, we need to run the this pairwise t-test statistics on the growth rate. Okay, and if we see that, so my question now is, I'm now opening it up to for the floor. I'll just, Nupur, just hang on. I'll just repeat the p-value part. But let me try to see whether you guys have understood what I've just now said. That, so here is the question. The question is, if after running the growth of both Adani stock and Tata Power stock, if I find that the t-test statistics is statistically significant, what does it imply? So let me write the question. If after running the pairwise t-test on the growth of Adani and Tata, we are getting a significant T. Okay. And how I know, this is coming back to the question which was raised, that how I know that the p-value or the t-test is significant, I will come to know by looking at the p-value. I'll just again repeat it right now. So here is the question. So if after running the pairwise t-test on the growth of Adani and Tata Power stocks, we are getting a significant t-test statistic. Okay, what does it imply? Let me open the question for the group. Okay, so this is my question, and let me see how many of you understood. So if after, what would be the degree of freedom in this formula is the two sample sizes are not same but different. I'll come back to that, Aditi. But typically what we are trying to do here is we are looking into the same number of observations. Okay, and as I said, that even if your sample size is different by 4 or 5, if I have a larger sample, when you actually work with the data, you actually run with 1,000 or like some of the work that we did, our sample size is more than 1 lakh. You know? So there it doesn't matter whether you have some uneven it matters in the context of panel, balanced or unbalanced, but overall, in terms of the test statistics, it does not matter much. Anyway, so I will come to that, but before that, let me ask you this question, and I've now opened this for everyone. What do you think? So Purnur is saying it implies that the difference that we come across is statistically significant, not by chance. Okay, so if this is coming out to be statistically significant, then what is happening is Adani is going to give you a better return. Yes. So that's what Vandana is saying, that if it is statistically significant, remember what is my X1? X1 is my Adani and X2 is my Tata Power. So if T statistics is coming to be statistically significant, and again, how I know whether the T statistics is statistically significant or not, I have to derive the p-value. Okay, so now let me repeat the p-value one more time. Again, the rule of thumb is if the p-value is less than, okay, less than 0.10, then it is statistically significant at 10% level. Okay, I'll again come back to the p-value. If it is less than 0.05, then it is statistically significant at 5% level. And at 5% level, and if it is less than 0.001, so typically when you work with the data, you work with this one. Okay, if it is less than 0.01, it is statistically significant at 1% level. So remember what was the value that we got? It is much less than 0.001, so it's highly significant. It's super significant. Okay, so and that does not surprise us because the mean value of Adani Power is greater than that of Tata Power. But let's try to do this. But before that, Nitu Suresh is saying degree of freedom is 9. Why, Nitu? I'm not sure why you're writing that. So anyway, so here we are actually losing 2 degree of freedom because we are operating with the mean. Okay, that's the estimated value, and that's why what I said, that you have to deduct it with 1, the number of observations. Okay. Now here, how do I calculate the growth rate? Now let's try to see which one is a better stock to invest. If I were to invest between this time horizon, which is 30th September 2022 up to, between 1st July 2022 up to 30th September 2022. Again, as I said, this is the real-time data which I have collected from this thing. Okay, so here I'm doing a mistake in the sense that ideally the growth rate should be calculated from here, because so you will have to change the data. But let's assume that this is 1st July. Okay, forget about this thing. So the formula for the growth rate is what is the formula? The formula is this one. So this one less this over this one. Okay, so this is what I'm getting as the growth rate. So that's my growth rate. Forget about this 2 last line because I'm not interested in the growth rate. And likewise, I can calculate the growth rate here. The same formula. Again, I do the growth rate here. So this is the growth rate I'm getting. So now let's try to do the t-test statistics. Here again, I have to do the mean. Okay, so all you have to do is to click test. And just to ensure that we are doing the correct, you see that again, the column is getting changed. Standard deviation, we want it to change from D2 to, actually this should be D3 to, because my data is from D3. But even as I said, that does not change much. You get the same formula, almost the same result. Because we are losing 1 degree of freedom because of growth rate. Okay, but in actual term, it doesn't change much. Okay, now had this been a physical class, I would have asked you to compute it yourself. But let us try to keep this as a homework. And let me give you the answer. This is the formula. Dr. Arjun is going to share this with you. You now plug these numbers, okay? You now plug these numbers. These are the numbers we have got. So plug this number over here. And here you will find that the t-test, let me also give you the final answer. The t-test is not going to be statistically significant, which means what? Which means between July and September, there is no significant difference in return between Adani and Tata Power stock. Okay. Clear, guys? Because what I'm getting, this is the result you should get, because I can still do it, do the thing, but I want you to do. I've done almost 99% of the thing. All you have to do is to put this number over here, okay? Instead of N1, N2 as 63, now you have to write as 62, but that's not going to change much. And you are going to calculate the t-test statistics on the basis of this formula. And the t-test statistics, once you get, you will find this t-test statistics to be very small. Okay? It will be like 1 point, or even it can be 0 point something. Okay, so let me show you. Let's assume that in this case you are getting a t-test. Just to drive home our point, let's say I'm getting a t-test value of 0.96. This I don't know what you'll get, but I'm sure you'll get a value less than 1. Okay, now let's try to compute the p-value of the t-test. Okay, so again, equal to t-dist. Okay, and here I'm getting 9.968. Degree of freedom would be 62 or 61, and 2 tail. You see, we are getting a t-test, the p-value of the t-test as 0.33. Earlier I was getting as 0. So remember, going by what I wrote over here, your t-test will be statistically significant if and only if this is less than 0.10. Okay, but in this case we are getting a p-value of t-test test statistics as 0.33. So let me open this up for some question. Yeah, so p-value, Surya Teja, you are asking that what is the p-value? The p-value is at 5% level. Okay, so that 0.05, the moment you write 0.05, it is at 5% level. The moment you write 0.01, it is at 1% level. The moment you write 0.10, it is at 10% level. Okay, so that's how you can calculate. Aditi is asking what should be the degree of freedom in this formula. Is the 2 sample? Oh, that's what I said, that it's not going to change much. You can actually experiment with the data. Let's say that you drop some numbers. Okay, you drop some numbers so that I have uneven sample. And so what is going to change is this one. Okay, and if you change the sample here, coming back to what Aditi's question is, then the N2 will get changed. Okay, please note this. The N2 is going to get changed because I'm dropping few observations. So let's say I'm dropping this few observation. So both this mean and this thing is going to change, as well as the N2. N2 is the number of observation for the Tata Power stock price. That is also going to change. But what is not going to change is the formula. What is not going to change is the intuition. What is not going to change is the p-value. What is not going to change is the t statistics. Okay. Does that answer your question? Hopefully. Garima is asking why it is 2 here, because Garima, you see that we have lost one observation here. Earlier we had 63 observation. We had 63 observation here. But the moment I'm calculating the growth rate, I'm actually losing another observation, right? So this is so this becomes not available because I'm calculating the growth rate. Okay. What you should do is actually, rather than you have to transpose this data, because the data is starting from 2000. So the growth rate will actually start from here. Okay. So that also you can do. You can go to the format set. You can go to where it is, copy, and then you can go to paste spatial, and then you can transpose this data, and then you can start from this thing. Okay. So it's pretty simple in that way. Any other question, guys, about this? What we did? So what we found was, again, to repeat, and why we did all this thing. This is because in the previous class I said that if you are getting a sample like this, okay, which one is a better sample? I did not actually introduce you to the concept of pairwise t-test, but today I actually introduce you to the concept of pairwise t-test. And I said that in absolute term, it does not matter, but what matter is you had mentioned p-value needing to be greater than, no, what I mentioned is this is the t value. Parul is asking whether, so Parul, please check this, okay? Oops. So Parul, there are two things I'm saying. That all I'm saying is if t-test statistics value is greater than 2.5, then the p-value of the t-test will be less than at least 0.10. This is for certain. So let's try to do this, okay? So let's say that just to drive home the point, here I'm saying it's 2.5, okay? Number of degrees of freedom, let's say it's 62, and two-tailed test. See, it is less than 0.1. Less than 0.1. In fact, it is significant at 2% level, okay? Because we are getting a value of 0.01. Okay, so is that clear? Who was asking that question? Parul. Is that clear, Parul? So we are talking about two things. One is the p-value. One is the t-test statistics. The other is the p-value. Okay. Now let me do something even more interesting, and then you will never forget what we are doing. Any question on this before I move to the next? Because what we are doing here is, if you remember, we were saying that this is a two-tail test. But many times we'll have to do one-tail test. Okay. Do you have any question? Okay. So this becomes much more interesting. Let's try to do this one-tail test. Now, how many of you have heard about VLCC? Have you heard about this, VLCC? How many of you are in the marriage market or going to get married soon? So if you are in the market for matrimonial, you'll find that VLCC is quite important. So what is VLCC? This is a center which claims that if you go there, you are going to lose weight, okay? And that is something which is, I think. So this data again I've collected from I think NFHS. And I've just calculated a part of the data, not the full data. Okay. And how many observation I have here? I have 100 observations. Okay. So this is your weight. This is your height. Weight is measured in pound. In India, we actually measured in kilograms. So it's roughly 0.45. 1 pound is equivalent to 0.45 kilograms, so that you can change. So roughly it will be like all the ladies between 45 and 55 kilogram of weight category. Okay. Now let's say that I'm VLCC. I'm the owner. I run this gym or weight loss center, and I'm claiming that whosoever is coming in my program, in this case, weight loss program, after 3 months or 4 months, you are going to lose your weight, or otherwise you are going to get back your money. Have you heard about something like this? Or for that matter, if I want to make it much more otherwise topical, even as recent as now, I think, one of the pizza delivery company, they are claiming that I think Domino's Pizza or something like that. They claim that if they are not able to supply pizza within 30 minutes, you get back your money. Okay. So how do I know what they are saying is true or false? So that's how this one tail test statistics comes in. Okay. So the the formula for the t test here is, in case of one tail test, is you have this, what I am saying, that the belief, okay, or the claim, or the population parameter, okay, and we also have this other thing, which is the sample. So in the case of Zomato, in the case of this pizza delivering company, what I was saying that Domino's Pizza is saying that if they cannot supply within 30 minutes, okay, they are going to give you back the money. So the 30 minutes become my population parameter, and the sample statistics is something you collect from the sample. Okay. So here, any question? What I'm trying to argue, or please ask question if you have. So here, let's try to do this. Okay, so this VLCC, which is this weight loss, they're trying to reduce weight. They are saying that if you go to their this thing, your weight will be less than, randomly, let's take their weight will be less than 88. So this is what, this is the population. That's what they're claiming, 88 pounds. If you go there now, someone from outside said that, well, I have collected the sample, and this is what I'm getting as the weight. Okay. So this is what I'm getting as the weight. So how to ensure what they are saying? So this is my sample. Okay, please don't get confused. So VLCC is saying that, again, I'm repeating one more time because this can get confusing. 99% of the people, they don't understand about one tail or two tail test, and therefore I'm trying to give you more time in order to make you understand. So the VLCC is claiming, if you are going to their weight loss center, your weight is going to be less than 88 pounds on average. Okay, so this is the sample I've collected. So I need to see that. So what is the so whenever I use the word claim, that is my alternate hypothesis. So, and you also have null hypothesis. So what VLCC is saying, that if you come and join our program, your weight weight is going to be less than 88. What is the null? Your weight is greater than equal to 88. Okay, so we are now going to test this hypothesis. Okay. Any question, guys? Are you following what I'm saying? Please understand, because this is very important, yet very basic, and you can do a lot of things on this. Okay. Now, if I'm a critic of, let's say I'm a competitor of VLCC. Let's say I have my own gene. Okay. So Nilanjan has opened, so it's called Nil gene. And I'm saying that whatever VLCC is claiming is actually false. Okay. So then what is my null? In my case, the null hypothesis is, can someone say what would be the null? Here I'm claiming that whatever VLCC is saying is false. So basically as I said, I will have to go with my alternate. In my case, the alternate is weight is not going to be less, but it is going to be more than 88. And here in my null is weight is equal to. So this is the competitor's gene. Nupur is saying, sir, null will be the weight, not equal to 88. Null is always either greater than equal to or less than equal to, because we are dealing with, so keep that in mind. So let me repeat. Null is always greater than or less than, okay, equal to. Alternate is strictly greater or less. Okay, so keep this in mind, don't forget. And what is the other thing I was trying to tell you guys? The other thing I'm going to tell you is, so in terms of hypothesis, both these hypotheses are correct. It depends on whose side you are taking. Okay, so yeah, so Vaishali, glad you asked this question. So this, whenever we are doing or writing like this, you see, this is basically one tail test, because it is strictly one tail test. Okay, because had this been two tail test, I would have written this as weight not equal. Okay, not equal. Okay. So in case of two tail test, something we did in the context of the previous example, Tata Power and Adani Power. Here also null hypothesis would be weight is equal to, yeah, 88. Here guys, so this is the crux, and I'm telling you, even if you talk to many of the professors, they don't understand this, with all due regards. Please ensure intuitively you understand this, because otherwise you are not going to. I'm actually highlighting this so that you don't forget. Okay. So in case of one tail, always you will find strictly less than or strictly greater than, and there is no right or wrong. It depends upon which side you are taking. Okay. And in case of null, in case of so this will be two tail test. Okay. So this will be two tail test. So this will be two tail test. So for two tail test, this would be. So this is a two tail test. Let's take it over here. So in case of one tail test, you have this greater than equal to. In case of two tail, this is Is it clear? Any question? Anyone? Any question? Please ask. Sir, alternative and null hypothesis should be reversed. Yogesh, doesn't matter. It depends upon whose side I'm taking. If I'm taking VLCC side, then they are claiming that alternate. So it's about you go with the. So you want, if you are VLCC, you want this alternate to be correct. So you choose the side, you choose the alternate which you want it to be correct. Okay, so for me, I have opened my own gym and I'm competing with VLCC. I want VLCC is not correct, so my alternate is VLCC is not doing a great job. Now let's try to see, going by this example, whose claim is correct. Okay, is that clear, Yogesh? Yeah. So yeah, so now you have understood. So basically now let's try to see that I have this two party, and yeah. And so I have collected the sample. This is the sample. So this is my sample. And now let me also write the test statistics. The formula for this is quite simple. So this is the formula: x minus, let's say this x is the sample x. Okay, so let's call this x bar minus, let's say mu bar. Okay, mu bar is coming from the population, x bar is coming from the sample, and you have this over the standard deviation of the sample. So this is my standard deviation of the sample over you have this the number of observations. Okay, so the square root of number of observations. Just check whether I'm writing it correctly or not. Okay, so so far you understand the intuition, it should be fine. Okay, so this is the formula. So the thing is, you can actually do this right now. So you have this average. So this is my average. And I have the standard deviation. This is my standard deviation. So this is my mean width. And this is the standard deviation. So this is what I've got. And let's see. So now all you have to do is to plug and chug. What is bar? Mu bar is the population. So this is 88. So what I'm getting is 91. So this is the formula. So 91.72 less 88. This is what I'm getting, 3.72. What is 3.72 again? 3.72 is this part over here. And now I have to do this part. Okay. So this is actually, S is how much I've got. S is the standard deviation over square root of, what is the total number of sample size here? It is 100. Yeah, so it will be 10. So 10. So this is what I'm getting. Now, what is the value of t-test here? This is this. over this. So it's coming to be highly significant, which is basically saying that what VLCC is claiming is correct because your t-test statistics is coming out to be statistically significant. This you can check using that formula equal to t-test 9.89. Degree of freedom will be 100 minus 1, 99. I'm doing one tail test. This is what I'm getting here. It's highly significant. It's almost like there are 17 0 before 9. Okay, so basically I'm being jealous and my claim is not correct. What VLCC is claiming is totally correct. In fact, if you go and join their program, you will see that you actually lose weight. Now, Parul is asking a question that, okay, there are a few questions, so let me take one by one. So Vaishali is asking, two-tail is basically to understand direction, right or wrong? Yes, Vaishali, so it depends. So in my case, you see that when I'm running my one-tail test over here, this is actually, it is greater, right? So my critical region will fall on the right side, okay? But if I'm running this one, my critical region will, this is less than 88. So in this case, the critical region will follow on my left side. So if you remember, when we are drawing that bell-shaped curve, you have the right tail test, you have the left tail test. So this is, again, let me write, this is my left tail test. So the critical region will be on the left, okay? And so that's why we call it left tail test. And this one would be right tail test, and therefore my critical region will be on the right side, okay, on the right side of the distribution, yeah, the distribution. And in case of two-tail test, the critical region will be both on the right and left. Okay? So the point to note here is, which is again very important, is in the case of two-tail test. So if I'm doing one tail test at 5% level, if I'm doing one tail test at 5% level, right? Sorry, 5% level, one tail test at 5% level is equivalent to 2.5 is equivalent to two tail tests at 2.5%. Okay, so basically you are actually sharing the mass. Okay, so that's okay. So Parul is asking, is one tail or two tail which is more important? Doesn't matter, Parul. It depends upon what you want to test. If you're testing that, if this is what I'm testing, then of course one tail test. And if this is what I'm testing, it has to do with two tail test. Okay, so it depends upon what you want to test. Okay, so Aditi is asking, what would this test look like? So Aditi, actually, this test will look like this one. Okay, so my claim, I can still do the same thing. You know, it's still the same thing. In the sense that I am claiming that they are they are not going to lose weight. So basically, this is the sample. Okay, so whosoever is so in order to prove my claim to be correct, ideally this this thing should be much less much less than what we are getting. So, so the, wait a minute. I think what I said, X bar is, I'm getting 91, right? So X bar, I'm getting 91, and this is statistically significant. So in this case, actually Neil is correct. Sorry, because alternate is what VLCC is claiming. VLCC is claiming that their weight is less than 88, but I am claiming that your weight is actually greater than 88. And this is exactly what you are getting from the sample, which is 91.72. So basically, my claim is correct that you should come and join my gym, because what is happening is, in terms of the sample average, the sample average weight is than higher and statistically significant than what VLCC is claiming. Okay, so here Neil is correct, which is why you should come and join my gym. Okay, any question, guys? Yes, thanks, Aditi. So the next time you come in Hyderabad, come and join my gym. So this is quite fun, because once you have the data, once you have understood the one-tail test and two-tail test, you can actually do a lot of things without going into much more sophistication. Because now what I'm going to do is, in the next class, I'm actually going to run the multiple regression. This is even more interesting. It becomes much more interesting, and show you that how to analyze, or how to check for the data, or how to check for the variable, or how to do the modeling part. Which are the variable I should include, which are the variable I should not include. And all of this depend upon what is on the basis of, again, three things. Just to give you a heads up, one is t-test. We'll be using t-test. We will be using f-test. Yeah. So let's try to entertain a few more questions if you have. Sorry, I don't understand this. If we are deciding whose claim is correct based on average alone, why would we need to run t-test and check? Yeah, because this average value, the weight that you are getting, is on the basis of the sample you have collected, Aditi. So you'll have to believe some sample, right? Because otherwise, how will you do the statistically significant? You will have to collect the data, right? So for instance, again, that pizza delivery example, which I was trying to give you, when I was trying to say that Domino is claiming that they are actually giving pizza within 30 minutes time, and let's say that some of the consumer, some of the people who are buying from Domino's, they are claiming that their pizza is getting delivered more than 30 minutes time. So how I know whose claim is correct? For that, you'll have to collect the sample, right? And once you collect the sample, you'll have to do the testing on the basis of t-test test. Only then I should be able to understand whether what they're claiming. It's like this. If you go to a court, okay, if I've committed some crime and I've hired a lawyer, he's going to always claim that I'm innocent. But the lawyer which is appointed by the government, or the public lawyer, he is going to claim that I am not innocent. So whose side, who is correct? For that, you'll have to run the sample, or for that. So in this case, just to ensure that both of you, let's say I have now a different sample, okay? I have a different sample, and on the basis of that, here I'm getting mean weight as, let's say, 86. Then, of course, if I'm getting mean weight as 86, then what VLCC is claiming is correct, not me. Okay, so that's how you do the one tail or two tail. it's totally driven by the sample that you're getting in hand. It's nothing to do with who is correct, or because I would always try to argue my alternate is correct, because or VLCC is always going to argue its alternate is correct. So whosoever, so you take the side of the alternate always. Okay, so if I were VLCC, I would take this side. If I were Neil, I would have taken this. Okay. Now, in order to here in the previous case, I said that Neil was correct because what VLCC is claiming is not correct. Let's say we have got another sample where I've got a mean weight of 86. Then of course the VLCC claim is going to be correct. So that's the fun part. You will have to collect the sample. You will have to then run the sample or collect the sample statistics. And on the basis of the sample statistics, you are going to say who is right or who is wrong. Okay. Any other question, guys? As there are 10 minutes left, let me open it up. Any other question? So just to rephrase what we did both in the previous class and this class is why it is important for us to understand the distribution function or density function, because we wanted to know that how the outcome variable is behaving. Okay, so if the outcome variable is and more importantly, so in the context of the pizza delivery thing, the outcome variable is the number of minutes it takes to delivering a pizza. In case of this VLCC example, the outcome variable is the weight, whether people are actually losing weight or not. In case of this Adani Power and Tata Power, the outcome variable is the outcome variable is this thing, the growth rate, whether it makes sense to invest in Adani or this thing. Okay, I think Dr. Arjun is saying you can unmute and speak. So I think he has now given right to any one of you to ask questions. So please feel free to ask questions if you have.
You can raise your hand. Dr. Siva Shankari ji, you can unmute and speak. You raised your hand before.
Yeah, please ask the question. I'm not able to hear any question. Okay, so here what we have done is we have dealt with one variable, right? Because when we are doing this, either the growth rate or the weight, this is just one variable, and therefore we are doing one tail or two tail. In the context of multiple regression also, we are going to use the same intuition. We are going to use the same formula of t-test statistics. Here, what we are suggesting is, and this is the data that we are going to work in the next class, next Saturday, is I have, and this is also a real data. Again, when I was a graduate student at Utah State University, I actually went out and collected few data for my class project. Okay, and so what you see over here is the sales price of various houses in US dollar. Okay, and the sale price is a function of various things like the square feet area, lot size. Lot size is basically saying that how much extra space you have got for gardening and things like that. The year the house is built, the number of bedrooms, the number of bathrooms. And the reason why you see 1.5 or 1.75, they give 0.5 point if you have a small shower, or if you have a big shower, so on and so forth. Okay, that's how these numbers are coming. So basically, the idea is we wanted to test this hypothesis. So if someone comes and tell you that, well, what is your projection about the price of house in, let's say you are in Greater Noida region in NCAR, National Capital Territory region. So basically, using this multiple regression, we can actually predict what should be the ideal price of the house. What is the upper confidence interval? What is the lower confidence interval? And on the basis of which we can actually try to Okay, Yogesh is saying that can you please show how to calculate the key statistics value in Excel? Yeah, so Yogesh, what I've shown you is this is how you calculate the key statistics value. This is the formula. Okay, so this is the formula.